In a remote and largely forgotten corner of the world, tucked beyond the reach of highways, far from the chatter of modern cities and the touch of predictable weather patterns, something extraordinary is unfolding. At first glance, the landscape is exactly what it has always been: arid, hostile, and aggressively silent. The ground is sun-scorched and fractured, a mosaic of dust and jagged stone that crunches beneath every step. Not even the hardiest weeds grow here. Locals call it the Dead Valley, and for centuries, it lived up to that name: nothing but wind, rock, and the echo of desolation. But now, something is changing. Something is awakening beneath the cracked surface, and it has left scientists, researchers, and even the most skeptical observers in absolute disbelief. They say it began without fanfare: no storm, no flood, no tremor to hint at what was to come. Just a glint, barely noticeable, caught by a pair of curious eyes during an early morning trek. A faint shimmer at the base of the hills, where the land dips into a basin that should, by all geological records, be dry. And yet there it was, a glistening stretch of blue, small at first, almost an illusion. But over the following weeks it grew. It widened. It deepened. And with every passing day, the impossible unfolded. A lake was forming. Not a puddle. Not a seasonal pool. A full-fledged, steadily expanding body of water in a place that has never, not once in recorded history, supported one. The news traveled slowly at first, whispered among a handful of nearby settlements and local travelers who had stumbled upon the phenomenon. But as word spread and the photos began to circulate online, it didn't take long for the scientific community to take notice. At first, many assumed it had to be a hoax, a doctored image, a misinterpretation of seasonal runoff, perhaps even a publicity stunt. But when environmental teams arrived, carrying the full weight of academic scrutiny, what they found was undeniable: the lake was real. And it was rising. What perplexed scientists wasn't just the presence of the lake, but everything about it. It wasn't fed by any known river. There had been no recent rainfall, certainly nothing of the volume required to produce even a fraction of what had collected. Groundwater mapping revealed no nearby aquifers that could have broken through. The land had never been a catchment zone. Yet the water levels rose slowly, consistently, with a pace and precision that didn't match any known environmental behavior. It was as though the earth itself had decided, inexplicably, to pour water into this once lifeless basin. And this wasn't just any water. Early samples showed unusual purity, low in sediment, lacking the typical mineral profiles seen in natural lakes. It was cold, unnaturally so, and its temperature did not fluctuate with the surrounding air as one would expect. Its clarity was unnerving. Beneath the surface, the basin plunged into a depth far greater than its appearance suggested. No algae. No fish. No life. Just water. Pure, silent, still water, spreading, deepening, and resisting every attempt at explanation. In geological terms, lakes don't just appear. They are the result of long processes: glacial retreats, tectonic movements, erosion, man-made dams. Every body of water on Earth can be traced to a source, a cause, a history. But this lake had none. It did not exist on any map, old or new. It was not a revival of an ancient body long since dried up. Carbon dating of the basin soil confirmed it. This land had been dry for thousands of years. Some sediment layers showed no evidence of water presence stretching back over 10 millennia. This was not a reawakening. This was something entirely new. A lake born without origin. And the questions kept multiplying. What mechanism could explain this phenomenon? Why had no seismic activity been detected in the area? Could it be underground pressure forcing up ancient water? But if so, why was the water so clean? So cold? Why wasn't it tainted by sulfur or trace minerals from the surrounding rock? Why now? Why this place? Satellite imaging from the past several decades was pulled and analyzed frame by frame. The result was chilling. There had been nothing. No moisture, no shadows, no signs of soil saturation. And then, within the last few months, a change. The land darkened slightly, subtle, almost imperceptible, followed by the sudden appearance of reflective light, indicating water. From there, the growth was exponential. What started as a glimmer had become a mirror to the sky. And if all of that wasn't strange enough, there was the shape. Viewed from above, the lake didn't form a random, natural outline like most bodies of water. Its edges were unusually smooth, curved with an eerie symmetry. Some observers noted the faint geometry of it, oval, almost perfect, as though it had been etched into the earth rather than carved by nature. There were no tributaries feeding it. No natural spillways. Just a deep, unnatural bowl filling steadily with water that shouldn't be there. Local legends began resurfacing. Stories once dismissed as myth or superstition took on new life. Tales of a buried spirit, a sealed gate beneath the ground, a place where the earth once bled. Elders in nearby villages spoke of dreams, shared dreams, of water swallowing the sun and a lake that mirrored not the sky, but another world entirely. The scientific community didn't indulge these tales, of course. But in hushed conversations, away from the media, more than a few researchers admitted to a growing unease. The deeper they dug, both literally and figuratively, the less sense it all made. This lake wasn't just a geological anomaly. It was a challenge to the very framework of Earth science. It shouldn't exist. And yet it does. And it's still rising. Before we continue, we would like to remind you to subscribe and like the videos so we can continue making more content like this. As researchers settled into makeshift camps on the lake's edge, bringing with them weather instruments, sonar gear, and satellite uplinks, the air grew thick with tension. There was no media frenzy yet, only whispers, quiet footsteps crunching over brittle earth, and the occasional buzz of a drone capturing sweeping aerial shots of the impossible mirror slowly stretching across the land. Behind closed doors, theories began to form. Charts were drawn, models built, and one idea started to gain traction, cautiously at first, then with increasing seriousness. Could this lake be the result of ancient, long-buried subterranean water sources, an underground reservoir finally surfacing after millennia of containment? It was a logical place to start. After all, aquifers are known to lie deep beneath the Earth's crust, sometimes untouched and unmeasured, locked away since prehistoric times. In rare cases, geological shifts, especially in remote regions with minimal seismic monitoring, can crack open these hidden vaults, releasing pressure and allowing water to rise. It wouldn't be the first time that an ancient water source had surprised researchers. But this was different. Geologists began scanning the surrounding terrain for any signs of fault lines or recent subsurface movement. They expected to find shifts in rock strata, minor tremors, anything that might suggest an underground breach. But the results were empty. The bedrock showed no new fractures, no tectonic pressure points. The soil compression levels were unchanged from historical readings taken decades earlier. Even the magnetic field of the region was calm. If the Earth had opened a hidden gate beneath this lake, it had done so without leaving a single fingerprint. Still, the idea of a subterranean origin clung to the minds of those desperate for logic. Teams brought an advanced ground-penetrating radar, hoping to map the hidden structures beneath the surface. What they found only deepened the mystery. Beneath the lakebed, instead of the expected layers of sediment and porous rock that typically cradle groundwater, there was a strange pattern of tightly compacted clay-like material, dense and uniform, almost like a natural barrier. And yet, water was rising through it, slowly and steadily, as if seeping through something not quite rock, not quite soil. One geologist described it as feeling like the earth had been sealed there on purpose. This shouldn't have been possible. That kind of material should have acted as a plug, not a conduit. Yet the lake continued to expand, its shoreline creeping outward every few days by inches, sometimes feet. And no matter how much water rose, the composition didn't change. It remained crystal clear. It remained cold. One hydrologist, brought in from a major university, proposed a controversial refinement to the underground water theory. He suggested that perhaps this wasn't just ancient groundwater. Maybe this was fossil water, trapped beneath the crust for tens of thousands, possibly even millions, of years. Water untouched by light or life since the Pleistocene. If true, it would make the lake not just a mystery, but a discovery of profound scientific significance. This kind of water, if studied properly, could provide clues to the Earth's climate before human civilization began. It could reveal microbial life frozen in time, perhaps even materials or isotopes no longer found on the surface. But again, the data refused to comply. Isotopic analysis of the water yielded baffling results. The oxygen and hydrogen signatures didn't match those of typical fossil water reservoirs found in arid regions. In fact, some of the isotopic values were so skewed, they seemed to suggest the water had never undergone surface evaporation at all, as though it had not been part of Earth's water cycle. Not rainwater, not glacial melt, not anything that could be traced through hydrological modeling. It was as if the water had bypassed every known route into existence. Still, the fossil water theory clung to relevance, not because it fit perfectly, but because it was one of the few ideas that came close to explaining what was happening. It was something to grasp in a storm of contradictions. Scientists began to theorize, what if there was a previously unmapped underground chamber, sealed off and insulated from tectonic movement, that had just now, for reasons unknown, begun to exhale its contents? What if a chemical or thermal shift had changed the permeability of rock deep below the crust, allowing a slow bleed of water into the basin above? These weren't comforting theories. If true, it meant there was something we had overlooked about Earth's internal structure, something capable of storing not just moisture, but immense, undisturbed volumes of water for untold ages. But even these ideas started to crumble under scrutiny. Aerial surveys revealed no sinkholes, no terrain instability, no signs that pressure had forced its way upward. If the Earth was releasing water, it was doing so with surgical precision. No quakes, no gas releases, no upward push of displaced sediment. Just calm, cold expansion. And all the while, the lake grew. Measured. Patient. Unnatural. Some in the camp began to whisper, scientists who prided themselves on rationality, but even they couldn't help it. What if this wasn't natural at all? They murmured over late-night coffees, eyes darting to the still lake in the moonlight. What if this was engineered? Not by man, but by something else? The official reports wouldn't mention those conversations. Not yet. But behind every scientific paper and clean press release, there were unspoken questions lingering like shadows. And as the first explanation began to lose its footing, underground reservoirs, sealed aquifers, prehistoric vaults of water, another, even stranger theory began to circulate. With the underground reservoir theory slowly collapsing under its own weight, the scientific community at the lake began to shift their focus. Not because they wanted to, but because they had to. The evidence simply refused to align with what they knew. The data was obstinate, unmoving, almost mocking. Water was appearing in a region where no known process could explain it. The Earth had offered up a mystery, and now it was time to consider possibilities that sat just outside the usual frameworks of geology and hydrology. One evening, under the soft hum of field lights and the distant call of nocturnal animals, a climatologist named Dr. Eva Lemoine stood before a digital display in the Mobile Research Center, her eyes flickering between satellite images and infrared overlays. She didn't say much at first, but when she finally did, her words were quiet and strange. What if it's not coming from beneath us at all? The room went still. Heads turned. A few chuckled. But no one dismissed her. Not completely. Because in truth, everyone in that room had already asked themselves the same thing in the quiet corners of their minds. If the water wasn't rising from below, and it wasn't falling from above, then where? Dr. Lemoine elaborated. Over the past several months, satellite imaging had been showing subtle but consistent anomalies in atmospheric water vapor concentrations over the region, odd microbursts of condensation that appeared without a source. These weren't normal clouds. There were no associated storm systems, no temperature dips, no predictable weather behavior. Just sudden, localized humidity spikes in a place where such patterns had never been recorded. And always, those spikes appeared just before the lake's water level rose. It led her to a controversial suggestion. What if the lake was being formed by atmospheric injection? The idea on its surface sounded absurd. But she wasn't talking about human intervention, no government experiments, no weather control theories, nothing that veered into conspiracy. She was speaking strictly within the realm of atmospheric science, tiny, invisible phenomena that perhaps we simply hadn't detected until now. She hypothesized that under extraordinarily specific conditions, the atmosphere itself could act as a delivery system, a medium for transporting water vapor in quantities far greater than previously thought possible, and condensing it into a fixed location. It would require something unknown, some catalytic trigger, maybe a thermal anomaly, maybe a shift in pressure gradients, or maybe something completely off-book, an undiscovered process that allowed moisture to bypass the usual boundaries of precipitation and gravity. To demonstrate, she pulled up a graph showing thermal imaging overlays over the lake basin. Each time the lake expanded, the air above it had registered a faint spike in stratospheric refraction, barely perceptible shifts in how satellite signals bounced through the airspace. These shifts weren't random. They were concentrated in a dome-like radius above the lake, like an invisible lid forming temporarily, then vanishing just as quickly. Other researchers were skeptical. Some thought the data was noise, bad sensors, faulty reads. But they couldn't replicate the readings elsewhere. The distortion wasn't present over any nearby regions, only here, directly above the rising lake. And it kept happening. Dr. Lemoine posed a new question. Could there be a naturally occurring but previously undocumented phenomenon where moisture is being gathered and focused into a single point from a broad atmospheric net? Not rain, not mist, but a kind of non-visible condensation event that bypassed normal stages entirely. In her words, imagine a lens focusing sunlight. Now imagine an invisible lens focusing vapor. She coined a term for it, half-jokingly, atmovaulting. The concept was wild, but intriguing. If something, natural or otherwise, was focusing moisture into one spot, then that spot could, theoretically, build a lake without precipitation or underground sources. It would be the equivalent of wringing out the sky without ever forming a single cloud. Skeptics were quick to point out the missing variable. What's doing the focusing? And why now? No natural land formation had the capacity to produce such effects. Mountains, ridges, valleys, nothing around the lake's perimeter suggested any terrain-induced funneling of vapor. No geothermal activity. No electromagnetic pulses. Nothing showed up on magnetometers or seismographs. But Dr. Lemoine pressed on. She began consulting with atmospheric physicists who specialized in exotic phenomena, strange cloud structures, rare forms of ball lightning, even reports of localized plasma formations seen only under precise meteorological conditions. One researcher brought up the concept of sky rivers, massive, high-altitude moisture bands that carry more water than the Amazon River and stretch for thousands of miles. Normally, they affect coastlines and mountain regions. But what if one of those rivers had fractured, broken off, or had been subtly rerouted? It raised a disturbing implication. Something might be guiding it. Could there be a natural attractor, a gravitational quirk, a field distortion localized to this region, pulling the sky river downward, concentrating it? Again, nothing about the land explained it. No abnormal gravity readings. No deviations in Earth's geomagnetic field. And yet, the lake kept growing. And with every inch it rose, so too did the sense that the world was watching something utterly new. Something not written in textbooks. Not taught in labs. Something that sat in the dim space between weather and geology. Between atmosphere and surface. Between the known and the unnamed. As Dr. Lemoine's theory hovered on the edge of scientific acceptance, another question began to form. A question no one yet dared to voice aloud. If the lake is being fed by the sky, what happens when it's full? As the field teams delved deeper into the possibility of atmospheric injection, this bizarre mechanism of concentrated vapor condensation, attention turned toward instrumentation. If this process was truly occurring, it had to leave traces in the data, faint though they may be. So the researchers expanded their monitoring grid. They deployed high-altitude weather balloons equipped with ultra-sensitive hygrometers and spectrometers, floating upward into the troposphere and brushing the lower stratosphere, hoping to catch a glimpse of what couldn't be seen from the ground. The results were astonishing. At altitudes ranging between 7,000 and 9,000 meters, each balloon recorded a sudden, highly localized uptick in water vapor density, so concentrated, in fact, that it defied typical atmospheric dispersal models. These readings weren't consistent with ordinary evaporation or cloud formation. There were no fronts, no wind shear, no barometric signatures that matched the behavior of storm systems or low-pressure events. The air above the lake wasn't behaving like air should. It was heavier, saturated in a way that didn't belong to that region. Moreover, these moisture-rich pockets didn't drift. They didn't scatter like typical vapor clouds caught in high-altitude winds. Instead, they hovered, held in place as though by some invisible net. Observers likened them to stationary blisters on the sky, pulsing faintly on thermal maps, refusing to obey the currents around them. Scientists began referring to these anomalies as vapor anchors, fixed points in the sky acting like collection wells for atmospheric water. And the strangest part? These anchors only formed directly over the lake. Nowhere else. Not even a few kilometers out. The moment a balloon drifted beyond the perimeter of the lake basin, all anomalies ceased. Normal readings returned. This raised more questions than answers. Why this lake? Why this precise location? The atmosphere shouldn't choose a site. It shouldn't know where to drop its moisture. Yet every instrument, every reading, pointed to a deliberate concentration. Some theorists speculated about natural resonance frequencies in the terrain below, a sort of harmonic feedback loop between land and sky. Perhaps subtle oscillations in the Earth's crust, entirely undetectable by traditional seismic gear, were acting as a beacon, drawing moisture from the atmosphere like a tuning fork attracting sound. Others pushed into even more complex ideas: atmospheric electromagnetism, piezoelectric charge accumulations from mineral compression deep underground, or even the possibility that the lake was part of a new kind of climate pattern, one that scientists had never recorded before simply because it had never happened in human history. One fascinating observation came from a group studying biota near the lake's edge. They noted that plant life within a 200-meter radius of the waterline had begun exhibiting signs of accelerated growth. Not due to rainfall or soil richness, but something subtler, an increase in ambient atmospheric saturation. The air around the lake was denser, wetter, and marginally warmer. It was as though the microclimate was being terraformed in real time, reshaping itself to match the presence of the lake rather than the other way around. And here, the questions began to multiply. If the atmosphere was somehow being pulled into this fixed location, were we witnessing a feedback loop? A self-sustaining process? One that could perpetuate itself for months, even years? That would mean the lake wasn't a temporary anomaly. It was a system in motion. A kind of environmental machinery operating beneath our understanding, possibly escalating. That idea terrified some researchers. Because if the process was escalating, then there was no reason to assume it would stop at a tranquil lake. What if the vapor anchors grew stronger? What if the localized saturation increased to the point of forming hyperprecipitation events, massive, flash flood-level downpours triggered by an unseen hand in the sky? Or worse, what if the collected moisture reached a tipping point, becoming unstable, and releasing not as rain but as sudden deluge, a vertical flood, falling all at once? Still others theorized the involvement of a rare atmospheric instability, an unknown interface between weather layers, perhaps triggered by subtle shifts in global climate systems. Much like the way El Niño disrupts normal ocean currents, could there be an aerial analog? A sky-based phenomenon capable of pushing rogue rivers of vapor across the globe until they find a place to settle? If that were true, this lake might not be the only one. Some climatologists began scanning satellite data from other remote regions, deserts, high plateaus, sun-scorched plains. They were looking for signs, any signs, of similar microclimatic events, unexplained moisture spikes, sudden vegetation blooms, atmospheric flickers too faint to register on standard weather maps. And the deeper they looked, the more they found small hints. A cluster of inexplicable humidity near a dry basin in northern Chile. A sudden rise in soil moisture in a Mongolian steppe, without a drop of rain. Nothing as dramatic as the lake, but whispers. Echoes. Perhaps precursors. Suddenly, the team at the lake no longer felt alone. And that realization chilled them. Because if this was part of a broader pattern, if the atmosphere was indeed shifting in ways no one had predicted, then it might mean the Earth itself was adapting, responding to forces not yet visible, preparing for something. Perhaps the moisture was not simply appearing, but returning. Returning to places where, long ago, water once reigned. And if the air above the lake was remembering something ancient, something from a different epoch of Earth's history, then perhaps this lake was not a beginning, but a return to something we had long forgotten. Among the more speculative yet surprisingly compelling theories circulating within the scientific community is the idea that the lake's emergence is not solely the result of meteorological or geological factors, but a side effect of subtle geomagnetic interference, an invisible, shifting energy that may be warping localized environmental dynamics in ways not previously documented. While this might sound like something plucked from the fringes of theoretical science, the concept isn't entirely without precedent. The Earth's geomagnetic field is constantly in motion, pulsing, weakening, surging, even reversing polarity on a geological timescale. And while much of this activity goes unnoticed in everyday life, researchers have long suspected that anomalies in the field can sometimes trigger strange, isolated phenomena. In this case, the idea is that beneath the region where the lake now rises, an ancient and long-dormant magnetic conduit, possibly a fracture in the crust with ferromagnetic properties, has begun to reawaken due to subtle changes in the Earth's inner core rotation or mantle flow. As this conduit becomes active, it may be generating a highly localized distortion in the geomagnetic field, not strong enough to affect compasses or satellites, but just potent enough to subtly alter atmospheric and subterranean conditions. Imagine, for a moment, a kind of magnetic bubble forming beneath the surface, an unseen field that slightly warps the natural behavior of moisture, energy, and pressure. If such a field were to extend vertically, even marginally, it could potentially pull in ionized particles from the atmosphere or trigger electrochemical reactions underground, leading to condensation in pockets that ordinarily would never see water accumulation. While no instruments have directly captured such a field yet, some of the monitoring teams have reported faint fluctuations in magnetometer readings. Nothing large, nothing conclusive, but enough to make them pause. What's even more curious is that birds and local wildlife have begun behaving oddly near the lake's perimeter. Flocks of migratory birds have been observed diverting mid-flight, abruptly changing their courses well before they approach the area, an instinctive aversion that some ornithologists believe could be due to subtle magnetic disturbances interfering with their natural navigation systems. Similarly, reports from local herders claim that cattle and goats have become hesitant to graze near the expanding shoreline, often skirting wide arcs around it as if sensing something imperceptible to humans. If the geomagnetic anomaly theory holds even a grain of truth, it suggests something even more profound may be occurring, not just a rising lake, but a shift in the energetic blueprint of the land itself. This would open doors to phenomena we've never properly observed before, perhaps a form of hydrostatic attraction occurring in conjunction with weak magnetic fields, or even magnetically induced phase transitions where certain minerals in the subsurface release bound water under precise conditions. Some mineralogists point to peridotite, a dense rock rich in olivine, which can hold significant amounts of water locked away in its crystalline structure. If subjected to intense magnetic realignment or pressure redistribution, it's theoretically possible for this rock to release that water suddenly, effectively sweating liquid into nearby cavities that could gradually fill, pool, and eventually surface as a lake. Further complicating the picture is the potential for ancient, pre-existing voids beneath the surface, caverns, lava tubes, or fault line pockets, that may have acted as reservoirs, quietly collecting moisture from unknown sources over decades, centuries, or even millennia. The recent magnetic changes could have opened a path to the surface, creating the illusion of sudden formation when, in truth, the water had always been there, waiting. It's a haunting possibility that this lake isn't new in the truest sense, but a slow-dripping relic of hidden Earth processes, now uncovered by a quirk in the planet's shifting heartbeat. Yet despite the mystery, it's hard to ignore how precisely this event defies easy categorization. If geomagnetic shifts are involved, then this may not be the only location at risk. Scientists around the world have already been tracking minor pole wanderings and unusual magnetic spikes in regions previously considered stable. What if the lake is simply the first visible indicator of a larger transformation quietly unfolding across the planet? Could we be witnessing the early stages of an Earth-wide recalibration, one that manifests not through earthquakes or superstorms, but through subtle rearrangements of water, minerals, and energy? More radical voices have even drawn comparisons to the magnetic ley lines theorized in ancient geomancy, those hypothetical energy currents said to run across the Earth's surface, connecting sites of spiritual or geological power. While mainstream science often scoffs at such concepts, the unusual regularity of magnetism-related anomalies near sacred or mysterious sites has occasionally sparked renewed interest. Could this lake be rising at the intersection of such a line? Perhaps not due to mythic energy, but because the intersection points happen to align with ancient, faulted, or magnetically active crustal structures. It's speculative, yes, but not entirely dismissible. Because the truth is, the Earth holds countless secrets, buried beneath layers of rock, obscured by centuries of silence. And sometimes it doesn't roar when it reveals them. Sometimes it whispers. And that whisper might just be this lake. One compelling aspect that continues to pique the interest of geophysicists is the idea that geomagnetic interference doesn't always need to manifest as large-scale anomalies to have a substantial effect. In fact, microscale geomagnetic fluctuations, barely perceptible even by advanced instruments, can gradually influence systems over extended periods of time. These subtle fluxes, particularly in regions of high crustal sensitivity, might be quietly modifying the very balance of pressure and moisture deep underground. In areas where the crust is already fractured, mineral-rich, or compositionally irregular, even slight energetic shifts could trigger a domino effect. This would mean that the region beneath the mysterious lake might act almost like a lens or amplifier for geomagnetic movement, funneling these fluctuations into concentrated hotspots where they can affect physical processes in unexpectedly precise ways. More intriguing still is the possibility that this magnetically active zone isn't just impacting underground systems. It may also be playing a role in atmospheric water behavior directly above the site. Consider the concept of magneto-hydrodynamic coupling, a principle that, while largely associated with plasma physics, could theoretically have implications for ion-rich water vapor in Earth's atmosphere. In this context, electromagnetic fields might subtly alter the distribution of moisture-laden air currents, causing unusual rainfall patterns or atmospheric compression events right above the lake basin. Such changes might not register as abnormal in global meteorological models, but at the hyperlocal scale, they could account for strange surges of humidity, temperature fluctuations, or atmospheric pressure that accelerate the accumulation of water into the basin below. There's also emerging research into the effect of magnetically active zones on piezoelectric minerals, crystals that generate electric charge when subjected to mechanical stress. Quartz is the most famous of these, and it happens to be abundant in many ancient geological formations. When underground quartz-rich regions are subjected to tectonic pressure and magnetically fluctuating fields, they can emit subtle electric fields. Though these emissions are weak, in isolated environments with the right mix of pressure, mineral saturation, and trapped moisture, they may create pockets of ionization that alter the chemical behavior of the surrounding material. This could potentially lead to a phenomenon known as electroosmotic flow, where water is mobilized through porous rock via electric fields rather than traditional hydrological movement. Now imagine this process unfolding invisibly for decades, Slow, undetected flows of subterranean water migrating along electrically charged pathways, guided not by gravity or seismic shifts but by quiet pulses of magnetically stimulated mineral behavior. Over time, this trickle may become a stream, the stream a seep, and eventually, without warning, these hidden waters could burst forth into the open. The result? A lake that appears as if conjured out of nowhere, in a place where geological logic insists it should not exist. And then there's the question of timing. Why now? What has changed beneath the surface to awaken this phenomenon? Some researchers speculate that it could be tied to broader planetary rhythms, subtle, long-term oscillations in Earth's magnetic core, or even interactions with solar cycles. It's well known that the Sun's activity affects Earth's magnetosphere, and during peak solar activity, as in solar maximum years, the influx of charged particles can destabilize magnetic patterns on Earth. We may be living through such a window right now, one where the perfect confluence of solar energy, geomagnetic fluctuation, and crustal sensitivity has triggered a rare cascade of effects in this precise location. Others have looked even deeper, speculating whether Earth's mantle convection currents, which drive tectonic movement, might be interacting with lower crustal or even upper mantle magnetic structures in ways we barely understand. If large-scale convection is shifting or warping over time, it could realign ancient magnetic seams buried deep within the Earth, suddenly reactivating long-dormant zones of magnetogeological activity. In this light, the lake is not an isolated incident but a surface expression of a deeper planetary process, one that we're only beginning to glimpse. Then there's the cultural and historical dimension, one often overlooked in scientific circles. Ancient civilizations often built monuments, settlements, or spiritual sites in areas they believed had special energy. These locations, when mapped, often correlate with fault lines, mineral veins, and magnetic anomalies, suggesting that humans may have been intuitively aware of Earth's subtle forces long before they had the instruments to explain them. A curious correlation has emerged. Historical records indicate that this rising lake is located only a few kilometers from the ruins of an ancient structure, its purpose unknown, its alignment curiously oriented along a magnetic north-south axis. Could it be that even in antiquity, people sensed there was something strange about this place? Something unstable, perhaps sacred, perhaps feared? As speculation deepens, researchers are beginning to entertain the possibility that these rising waters aren't just a symptom of a geological anomaly, but the first visible signal of a broader shift in Earth's behavior, a faint murmur from the planet itself, hinting at forces in motion far beneath our feet. What makes this theory all the more compelling is that it defies conventional timelines. The lake didn't form in the aftermath of a storm. There was no earthquake, no volcanic tremor, no telltale sign of eruption. It simply appeared, gradually but relentlessly, defying all expectations. So while traditional hydrology, meteorology, and geology offer partial explanations, this theory urges us to zoom out, to see the event not just as an oddity, but as a symptom of a system responding to invisible levers we're only beginning to notice. It invites us to reconsider how subtle energy systems, magnetic, electric, and atmospheric, might conspire quietly beneath our feet, working not with explosions or eruptions, but with whispers. And in the silence between those whispers, something extraordinary may be rising. Now let's consider the possible ripple effects this rising lake could have on the world. When something as mysterious as this lake starts growing in size, it's not just a local issue. It could trigger a chain reaction that impacts everything from the environment to local economies, even reaching out to global concerns we might not expect. What happens when nature behaves in ways we can't fully explain? The answer could change everything we thought we knew about how the planet works. First, let's talk about the immediate surroundings. Imagine living in a town near this rising lake, maybe just a few miles away. As the water slowly begins to creep over the land, the first effect you notice is the change in the landscape. The rising waters could flood homes, roads, and entire communities that were never designed to be near a growing body of water. Local infrastructure, such as bridges, power lines, and sewage systems, could be overwhelmed by the sudden expansion of water. It's not just about getting wet, It's about losing things that people depend on to live their everyday lives. Local farmers would be hit hard. If the rising water spreads across arable land, crops that were once thriving could be drowned. With fewer fields to grow food, local economies might come to a halt. This could push the population of the area to look for safer, more stable ground, and that migration could have effects on nearby cities, overwhelming their resources and pushing up the cost of housing and essentials. People might even have to leave the area for good, abandoning homes, businesses, and traditions that have been in place for generations. But the impact doesn't stop there. As more and more people are displaced, the ripple effect spreads. Large numbers of refugees could start moving out of the area, creating a potential crisis that governments would have to address. The flow of people from a region that's increasingly becoming uninhabitable could strain resources in nearby towns, and that could lead to shortages of food, medicine, and water. The longer the lake continues to rise, the more pressing these challenges will become. It would become a global issue, not just an isolated incident. On a larger scale, we could start to see changes in the environment that echo across the globe. The lake's rising waters would not only drown land but could disturb the delicate balance of local ecosystems. For example, if this lake is growing due to underground forces releasing water that has been trapped for centuries, there's a chance that this water contains minerals or chemicals that could change the soil composition. The surrounding plant life and animal populations might not be able to adapt quickly enough. Invasive species could thrive, while native species might struggle to survive. The entire local biodiversity could be at risk. But perhaps one of the most alarming effects could come from the unexpected rise of groundwater levels. If the lake continues to increase in size, it could trigger a chain reaction that affects the underground water systems of neighboring regions. It's possible that what we're seeing with this lake isn't just an isolated event, but rather the sign of larger, more widespread changes in the Earth's crust that could affect underground aquifers. If these aquifers start shifting or leaking, whole regions could face water shortages. These underground systems are often a key source of drinking water for millions of people, so disruptions could cause a major crisis. Let's not forget about the long-term implications for global climate patterns. Some researchers suggest that changes in the landscape could impact local weather, and on a much broader scale, affect regional and even global climate systems. If this lake is fed by a hidden reservoir of water beneath the Earth's surface, it could be influencing the atmosphere in ways we don't yet understand. The rising of such a massive body of water could alter air circulation patterns, potentially triggering changes in rainfall distribution or even storm frequency in other parts of the world. The water from the lake could change the local microclimate too. As the water spreads out, it could cool the air above it, leading to changes in the types of vegetation and animals that can survive in the area. This might not sound like much, but a cooling effect in a single region could set off a domino effect of changing climate conditions in places far beyond the lake itself. Weather systems that are already on edge due to climate change might react unpredictably to this new influence, creating a snowball effect of disruptions that nobody could have predicted. Perhaps most alarmingly, the rising lake could become a symbol of the ways in which humans are connected to Earth's unpredictable forces. It's a reminder that despite our best efforts to control nature, we are still at the mercy of a planet that we don't fully understand. This mysterious event, unpredictable, terrifying, and yet fascinating, reminds us that our grasp on the environment is tenuous at best. It underscores how a small change, a single ripple in the Earth's crust, can send shockwaves through our world, affecting everything from weather to the global economy. This scenario isn't just science fiction. It's a reminder that our actions, or in this case, the Earth's natural processes, can disrupt far more than we expect. If this lake continues to rise, we might look back and see that it wasn't just an isolated event, but a turning point. A moment in time that reshapes our understanding of natural disasters, climate change, and even the way we think about the Earth beneath our feet. So, while this growing lake may seem like an oddity now, its potential to cause widespread effects, both locally and globally, cannot be ignored. It could reshape the landscape in ways we can't even imagine yet. And who knows? It could be the beginning of something much bigger than we're prepared for. The world might have no choice but to adapt, to learn how to live with these changes, or even to find ways to stop them before it's too late. It's a story that's still unfolding, and we're all witnessing it together. As we draw this investigation to a close, we are left with a profound sense of uncertainty and wonder. The rising lake that shouldn't exist has captivated scientists, locals, and global observers alike, triggering a wave of speculation, concern, and curiosity. From the moment this phenomenon was first discovered, it set in motion a series of questions that we are still trying to answer. How could a lake grow in size seemingly without any natural explanation? What forces are at play beneath the surface of the Earth? And perhaps most alarmingly, what will be the long-term consequences of this phenomenon? We've seen that the origins of this mysterious rise could be rooted in multiple factors. Initially, we considered the possibility of a natural, yet rare geological event, a shift in the Earth's crust, an underground water source being released, or the emergence of an entirely new fault line that we didn't know existed. Each theory presents its own challenges, not just for the scientific community, but for the locals who are witnessing the changes firsthand. The potential for such an event to disrupt communities, flood lands, and displace families is terrifying. The local infrastructure and agriculture are particularly vulnerable, and the displacement of thousands of people could create a crisis that reaches far beyond the immediate area. Then, we examined the role of human impact in this mystery. Could human activities have played a role in triggering this strange phenomenon? The idea of human involvement, whether through reckless water usage, mining, or the impact of climate change, introduces an entirely new layer of complexity. While it's still speculative, we cannot ignore the possibility that our actions might have set the stage for something we were unprepared for. If this is the case, it brings up even more pressing concerns about our relationship with the planet and how we manage the resources beneath our feet. Next, we ventured into more speculative territory, considering the idea that the lake's rise could be part of a broader, more mysterious force of nature. Could there be some sort of ancient, or even hidden natural force that is being activated right now? This notion is both fascinating and terrifying. If something like this were truly occurring, it would imply that there are vast areas of Earth's history and geology that we still don't fully understand. Perhaps there are ancient water reserves, fossilized in ways we can't yet comprehend, that are slowly being released, triggering unexpected changes in the landscape. As we explored these potential causes, it became evident that the consequences of this rising lake extend far beyond the immediate environment. In fact, the local effects could set off a domino chain of impacts that reverberate through entire nations, even across the globe. From local flooding to displaced populations and crumbling infrastructure, the immediate effects are disastrous, but the ripple effect could be even worse. The migration of people away from this disaster could create strain in neighboring cities and regions, potentially creating resource shortages and heightening social tensions. Economies could be disrupted as food production, especially in the agricultural sectors, is severely impacted. Looking at the broader environmental consequences, the potential disruption to local ecosystems is also a key concern. The balance of plant and animal life in this area could be threatened by the changing water levels, especially if the water has altered chemical properties that make the area inhospitable for native species. The invasion of non-native species could further complicate this delicate ecosystem, leading to long-term environmental damage. And beyond that, the global implications of changing weather patterns, disruptions to underground aquifers, and shifts in climate conditions could set off a series of challenges that we are not prepared for. Could this rising lake be a harbinger of larger environmental shifts? A sign that we need to rethink our approach to climate change and the way we interact with Earth's natural systems? In the final analysis, the rising lake that defies explanation is a reminder of our fragile place within the larger system of the planet. For all our technological advances, for all our understanding of the world around us, we are still at the mercy of forces that we don't fully control or even comprehend. This event, whether it turns out to be a rare natural anomaly, a human-induced disaster, or something else entirely, offers a stark reminder of the unpredictability of nature. The Earth, as much as we may study and understand it, still has the power to surprise us, to challenge our assumptions, and to force us to confront the limits of our knowledge. As we continue to search for answers, one thing is clear: the effects of this strange phenomenon will be felt for years, perhaps even decades, to come. The immediate implications for the people living near the lake are obvious: displacement, destruction, and hardship. But the global consequences could be far-reaching, affecting everything from food supplies and water resources to climate patterns and political stability. Whether we're prepared for it or not, the world will have to find a way to deal with this strange new reality. In the end, we are left with more questions than answers. Will scientists uncover the true cause behind this rising lake? Will we be able to adapt to the changes it brings? And most importantly, what will this teach us about the power of the natural world? The story of the rising lake is far from over. As we move forward, we can only hope that humanity is ready to face the challenges that lie ahead, challenges that could reshape our world in ways we can't yet imagine. Let us keep our eyes on this event and continue to watch as scientists dig deeper, communities respond, and the rest of the world braces for whatever comes next. This is a story that is still unfolding, and it has the potential to change everything we thought we knew about our planet and our place within it. Thanks for following along on this incredible journey. The answers might be just around the corner, or they might still be years away. But one thing is certain: this mysterious lake, and the questions surrounding it, will not be forgotten anytime soon. If you found this mystery as intriguing as we did, don't forget to hit that like button and subscribe to our channel for more deep dives into the unknown. Stay tuned, because we'll continue to uncover the hidden truths of our world, one mystery at a time. Keep exploring, and we'll see you in the next video.